and do it on your own.
Yeah.
Supposed to twist your nose and all that. Okay.
Sorry, I'm trying to get there. There we go. Okay.
Okay. So I am question 3. The normal probability applet. Hallelujah. Love that thing.
Okay.
Are we ready?
Okay. What about you, Brittany? You all there?
I'm there. I'm good, yes.
All right. So it says, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round your answer to the 3 decimal places.
Okay. So that's
0.175.
Yeah. So 0.175. All right.
Okay, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample means, or this cannot be determined. I think it's the first one. Because it's only 9.
Yeah, that makes sense.
Yeah.
If it was more than 30, then the distribution of the sample means would be
right.
smaller. Or am I thinking the mean? Well, am I on the right track there?
Okay, so I'm trying to remember. So you'll have the standard deviation will decrease as the population or the sample size or whatever increases. But I don't know. I actually think that's not something that we can tell from this information.
Let me look back on the lesson.
It's individual
Go back.
And well, no, I don't know. Don't listen to me. I don't know.
let's all review the lesson and see if any of us can find it.
It's hurting my brain. Let me grab the notes. Okay. Oh. Excuse me for a moment. I must go find my notes. They have jumped ship. Come on. Oh, that's not all of them.
Okay. It has to be in lesson 6.
That's what I was thinking, because I was like, I am not.
It's not in 7.
Okay, so all it says is the standard deviation of sample means decrease when the sample size is increased. That's all it says about it. Okay, so it's not big enough. for us to assume
Okay.
that-
Okay, I found it.
Okay, where is it?
It's in section 4 of lesson 6.
Oh,
It says the mean of the sample means is always aligned with mu. Also, if you took samples larger than n equals 1, the standard deviation of the sample means is always smaller than the standard deviation.
so we're saying the distribution of the sample means?
So, but it says if you took samples larger than n equals 1,
Is that what? That's what we're doing, though, right? Because it's 9 observations. So n equals 9, right?
right.
I'm not thinking of it right.
If the sample size is larger than 1, the standard deviation of the sample means was always smaller. Crap, I don't know.
That's like a trick question, I feel like.
The distribution of the sample means is always smaller?
It
It doesn't
says
talk about the distribution.
it says the standard deviation of the sample means was always smaller.
Yeah, well, that's what I thought.
If samples are larger than.
So these are.
So if the sample is larger than 1,
Okay, so X is individual observations, which is basically whatever, like that's the random variable that's included, right?
right?
Yeah.
So
So
that
so
can't
then,
be decided, and the sample means can't be decided. So I'm going to say it can't be determined.
yeah, because the answer is here, not
Okay.
the standard deviation.
Yeah.
No, but it's asking which one will have a smaller.
Yeah, but we don't know because we don't have.
No, it's
Oh, wait.
asking
We'll have a
the
smaller
distribution. Which one will have the distribution? So if 9 observations are randomly drawn from a population, like what's the distribution? Does that make sense? Because you can only answer the distribution of the individual observations, X, the distribution of the sample means X with that line over, or it can't be determined.
Wow, we're actually getting stuck on like the first question. This is lame. Are we overthinking it? Oh my god.
Yes, I know we are, because we're going to be sitting there going, duh, we know that.
Why don't we skip this one and come back to it?
Yeah, I think we'll probably figure the answer out.
Yeah, let's see.
Maybe the next question will give us the answer, something crazy.
Okay, which of the following results implies that the spread in the sample mean decreases as the sample size increases? Isn't that which one?
Is that the central limit?
The spread is the spread is law of large numbers and the shape is central limit, right? Or do I have it backwards?
Let's see. Central limit states that if the sample size is large, that X will be approximately normal. The law of large numbers states that the sample mean will be close to
Mu. Yeah. So.
It's the law of large numbers then.
Yeah. What? Well,
because the deviation is the spread. Like, so if the deviation is decreasing, then it's going to get closer and closer to the mean, which is the law of large numbers. That as the sample size increases, your distribution from the means decreases, which brings it closer together.
Yeah.
That makes sense.
I'm gonna go with the law of large numbers because, well, that one's the spread anyways. The other one's the shape. Holy crap! What
Right.
just happened? Apparently,
Okay.
my computer decided I was done and took me to the very bottom. So here I go back up. All right.
All right. Use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
Okay, so that's okay. Calculator.
I got 1.045.
Yep, that's what I got.
1.045, yeah. Yeah, 3 decimal places. I have to count. Didn't it come?
Okay, so what is the probability that a randomly selected student will score above 160 on the quantitative portion? So now we have to find the z-score with that other formula. And
No.
then put that into the applet.
I don't think so. I think we can just do.
Well, I guess it's exactly the same, yeah.
I was gonna say, would it be the same z-score because hers was 160?
Yeah, because they're only just asking about one. If one randomly selected, so yeah.
Yeah, so it's
0.148. Did anybody get that?
That's what I got.
Yeah. Okay. I had to find the applet because apparently that got close. But that's what I got. Okay, a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these? Of these students' scores? So you have to figure out the mean of their scores.
160.
Is it?
I put it in that Excel thing.
Cool.
So would it be the same as number 6 then?
No, because it's a sample of 5. So we have to do the.
So it's
So the mean is 160. So we would do the 160 minus the mean, 150.8. Okay.
Okay, so it's
9.2.
and the standard deviation is 8.
Divide that by 8.8 divided by the square root of 5. So 2.334. Anybody get that?
I'm having issues.
8.8 divided by the square root of 5. I got 3.94 or 93 5 for that one. But hang on. I don't think I worked
So
it
if
out
you
with
plug in the numbers, so the
Yeah,
I
I didn't
got
finish it out. I thought,
yeah, so the mean is 160 minus the standard deviation, which is 150.8. So that's the 9.2. And then divide that by 8.8 divided by
square root of
the
5.
square root of 5.
So I got 2.337.
Yeah, 7.
2.338.
Yeah. Rounded up. 8.
Okay.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? This time round it to 4 decimal places.
So we would just put 2.338 in the applet, right?
Right. And then only highlight the stuff to the right.
So 0.0097.
That's what I got.
Okay.
Yeah. So it's
It's way too much math.
4. That is 4 decimal places. Cool beans. I was about to figure out if I stick around. Okay, there we go. All right. And
Okay. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable, whatever that is, which represents the sample mean of the 81 students? So it would be approximately normal. Because it has a big sample, right?
yep, because it's over 30. Okay, so what is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population?
So the mean is just the mean, it's the same.
Yeah.
So 3.5, right? I have to keep reminding myself. I'm like, the mean is just the mean. It's just the mean.
Yeah, it doesn't change.
It doesn't
Yeah.
change. 3.5. Because law of large numbers. Yay.
Okay.
One less step.
All right.
Okay, 20.
All right. What is the standard deviation of the distribution of sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population?
So that,
That would just be the standard deviation divided by the square root of 81.
yes.
Which should be
It should just
9,
be 9,
isn't it?
So it's
I like how they're doing even round numbers like that most of the time.
No, isn't it wonderful?
So it's just 0.7 divided by 9, right?
Yeah.
Yeah, I got 0.07, lots of sevens.
Yeah.
Yes.
Round it to the 3.
So 0.078.
Okay.
Yeah.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So now we go back to the other, and we go 9. Wait, 9, not 9. Never mind. We go 3.3 minus
minus
the
3
3.5
divided
by
by 0.7.
0.7 divided by 9.
Divided by the 0.078.
Mm,
Yes.
no. Yeah, did you get negative 2.571?
I got negative 2.564.
Yeah, me too.
That could just be a rounding thing because you guys used the 0.7078 and I used the whole number.
Oh, yeah, that's probably true.
So I don't think we're supposed to round until the very end.
Right.
So do your calculation again, but this time use the whole number.
I didn't want to redo it. Just kidding.
I know. It's all those parentheses on your calculator.
Well, I know.
So negative 2.571.
Mm-hmm. So now we need the probability that it's less than that.
Oh, right. Okay.
So we want less 0.0051. Everybody?
Hold on. I am having issues.
I am too.
Okay. Yeah, I have 0051.
Yeah.
Yeah.
Good.
It says round to 3.
0.051?
0.005.
Yeah, 2 zeros. Could be less than. That does not seem right. That just does not seem right because that's less than 1 standard deviation away. And it's that small of an answer. That can't be right. I mean, right? I mean, just using the 68, 95, and 99.7 rule, that cannot be right.
Okay.
Something is off with our math. I don't know what it is.
We can take this twice, right?
Yeah.
Yes, we can. Okay. No, not that.
Okay, let's look here. Going back to question 12. I don't know, that has to be right.
Yeah,
I keep getting the same answer. And I've tried it like 3 different times.
Yeah. What is the probability that the GPA for 81 selected randomly students will be less than 3.3? So it's that x with the bar over it minus the mean divided by the standard deviation divided by the square root of 81. I mean, that is the equation, isn't it?
Yeah.
Hold on. 3.3. Yeah, I keep getting the same answer.
Same here.
I know, but you guys see what I'm talking about, though, right?
Yeah.
Yes.
Mm,
But that is 1, 2. It's 2.5 deviations from the mean. So, I mean, it makes sense.
but
Because
it's
it
not.
says that, but because it says that
Oh,
99.7 of the data is within 3. 95% of the data is within 2. And it's more than.
yeah, but what I'm saying is,
I mean, that's a 0.5%, basically.
hold on, was that?
So if 99.7 is within, 95 is within 2 standard deviations. So 2.5% would be left of the -2. And that's a 0.5%. So that makes, I guess to me, it kind of makes sense. If you convert it to percentages, like if you put it back into percent and not just the decimal.
Right, but what I'm saying is, if you minus, okay, so 3.3 is only 0.2 away from 3.5. The standard deviation is 0.7. So it isn't even a full standard deviation away from the mean GPA. It's not even 1 standard deviation away. So it should be less than 68%. Right? I mean, like in the middle, it'd be 68%. But in the middle right now, it's like 95% or 99% or something.
Right.
So the middle should only be, it should be less than 68%. It should be like, I think it should only be like 20 or 30% in the middle. So this number should be way bigger. Because I mean, just think about like the probability that 81 students would get less than a 3.3 GPA. I mean, I would think that'd be a little higher than 0.5%.
Right.
But if that's true, then where is the math wrong?
Maybe they did the math wrong.
Yeah.
Maybe it has something to do with the fact that it's a left skewed. No.
Because the next question talks about greater than 3.3. So it uses the same number again, just the greater than.
I think we just should, let's see. Bree, have you been writing down the answers that we've been getting?
Yep. Except for number 4, because we didn't decide on that one. But
We haven't decided on that one yet. I just
yep,
want,
I've been
because
writing them all down.
the math just seems like I don't, using the formula from the lesson, I don't know how we can get a different. I mean, I get what you're saying. Like, you're right. It doesn't make any sense.
But I don't know how else to change it.
I just don't know how else. I mean, we plugged in the numbers into the formula and that's what we're getting. So I guess if we get them wrong, then we can go back and look at it again.
Hold on. I'm trying something real quick. Let me see if I can get this to work.
That's cute.
Someone doesn't want to go to bed. I can't help you.
Okay, I think I figured it out. So we're not doing the sample of 81 because we're just doing the it's just what the z-score is, not the z-score of the sample populations or whatever. So you don't add the other part, you just do the number, which is 3.3 minus 3.5, the mean GPA, and then divide it by the standard deviation. And that got me 0.387, which makes a lot more sense.
But you have to calculate the 81 though. Because that answer would just be, what is the probability that just one person gets that?
I say we submit it with a 0.005. See if we get it wrong, and then we can come back and debate it. Because I feel like there's been a lot of times where we've been like, that was too easy.
Yeah.
And then we still got it right. Does that make sense?
Yeah.
Okay.
Because I've written everything down that we've gotten so far.
Yeah.
So we'll have to go back through and redo everything.
Like, yeah, we have to factor in the 81.
Otherwise, they wouldn't have put that in there.
Right.
Okay.
So on the next one, what is the probability that it's greater than 3.3? It would just be everything else. It would just be the 0.995.
Okay. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but raised after a tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that either a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this example. An extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in a positive direction. So let's math this one. So that's,
So do we use the mean of the 177.6?
yeah, so the 177.6 is
6 minus.
what,
Do we minus out the 185 or no?
so the mean is 185.
Okay.
That 177 is the sample, the variation or whatever. That's the X minus the population. And then we have the standard deviation and all that stuff.
So is it the 177.6 minus the 185 then?
Yes. Because
Divided by the standard deviation of 26.7 over the square root of 48.
okay, so yeah.
Is that the right calculation? Am I right there?
Yeah.
Yeah.
The square root of 48.
So negative 1.92.
That's what I got.
Negative 1.92, yeah. So wait. As extreme or more extreme? Above or below the mean? Does that mean that we need to go into the probability applet?
Yes.
And figure out, so it'd be above or below?
Well, that's a dumb question. What is the probability that somebody weighs more or less than 177.6? Isn't it just one?
How far? Because, well, maybe that shouldn't have been included. But I don't know what the other number would be if that's not supposed to be included. So that's like that's a variation of the one, oh no, that's right. So that's an extreme difference from 185. Except it's not really because it's less than a standard deviation. But whatever. But they want to know if the probability that people will weigh that far away, less or more. Which, you know, they've already done because they figured out the standard deviation. This is just lame. Whatever. It's delightful.
This is a trick question, and I'm tired. Somebody tell me what to type in. Because seriously, the way that I'm reading it is dumb. I don't.
Okay, so I went into the probability applet and I put in negative 1.92 and I highlighted the two side sections and not the middle because that's greater than or less than that number. My area is
0.0549.
Yeah. Does that sound good?
And round it to 3 decimals, so 0.055.
Yes.
Okay. Okay, let's go back to number 4 before we submit.
Oh yeah, we should probably pick an answer, huh? I don't know.
Eeny, meeny, miny, mo.
Pretty much.
I'm still going to go with our first gut feeling, which was the individual observations.
All right, let's do it.
Because isn't that what we all kind of agreed on first before we started thinking about it?
Yes.
Okay.
And then we just changed the minds. Oh, crap. Did I save that one? If I save dang it! I saved it, so now I have to go back and save it again. Or it's going to be saved as the other answer. Okay, save. Now I can go.
All right.
Submit. Why does it ask you to submit so many times?
That was wrong. Number 4 was wrong.
crap.
Why am I doing this? My phone is really driving me nuts right now.
But everything else was right.
0.0051 was right.
Oh, good.
So it was just number 4.
Okay, so what do we think number 4 really is?
Yes. Hold on. I gotta my washing machine is thumping bad. Hold on just a second. I'll be 2 seconds.
Okay.
Okay. So, are we retaking then?
Yeah, we can, and then if we miss it again, you still get a 94.
Yeah.
Okay. So, because it's just the better of the two, right?
It's worth a
What if it's
try,
different?
right?
You guys, what if it's a whole different set of questions?
It's not. It never is.
Are you sure?
Yes, I've retaken.
I've
tests
redone
on-
the homework quizzes. They're exactly the same, and I always write down the answers just in case.
Okay. Because I'm like, oh my gosh. In one of my other classes, if you retake it, it's a whole different ballgame. Dude. I'm like,
Yeah, I've got classes like that too, but that has not been my experience in
okay. Just because I'm like, we haven't actually had to retake a quiz yet, so just making sure. Okay, let's go back in, start the quiz, and then Bree, you can just read us all of our answers so we don't have to.
You don't want to redo all the math on this?
I don't think I can. I think we're lucky we got as far as we did. Oh my
I
gosh.
know, seriously, my brain is so asleep.
Be like,
Okay, what number did we get?
All right. Number 3, 0.175.
Okay.
Hold on, guys. My computer is flipping right the heck out. Okay, look. I get to go to the page. Stupid thing. Okay. It's 1.
0.175.
Okay. That's what I thought.
See, aren't you guys glad I write these down?
Yes.
Yes.
Probably. Probably. Gather. Okay. Number 4.
Number 4, we did the first one, the individual observations, and that was wrong. Oh, thank you.
Do we try sample means, or do we say can't determine?
Well, I don't feel like sample means ever got brought up when we were debating it, but that's just me. But,
Okay, what are we putting then?
Fine, we'll have a smaller standard deviation.
Maybe it can't be determined because we're talking about two different things.
Yeah.
Distribution.
Determined because we don't have any numbers, and honestly, I think that's the only way we could really tell.
Okay.
I don't know. That's my guess. I'm just guessing it. Someone else can guess something else, and we'll see who gets it right.
There we go.
Are we saying we can't decide?
I'm saying.
Ultimately, we get the same score anyway, so it doesn't really matter.
It's still an A.
Yeah.
Yes. Numbers.
All right, number 5, the law of large numbers.
Okay. Number 6.
1.045.
Oh, that's too many numbers. I fat fingered it. Whoops. Okay.
Do you want me to repeat these twice just in case, or just once?
I'm good.
This one.
Okay.
Once is good.
Okay. So number 7, 0.148.
Okay.
Number 8, 2.338.
Okay.
Number 9, 0.0097. Number 10 is approximately normal.
Okay.
Sorry. Number, where were we at? 11
Yep.
was 3.5.
Oh yeah.
Yep, 11, 3.5.
Okay.
Number 12 is 0.078.
Okay.
Number 13, 0.005. Teen is 0.995. And number 15 is 0.055. Any questions?
No, I think we're good. Oh, wait. Here. I got it wrong again.
Dang it.
Oh well, same score. That's still good. Okay.
All right. Need to that rule. But still, we did it. We're good.
Nice.
Hallelujah.
All right.
Okay, good job.
Thank you.
We have succeeded.